Welcome to my channel Study with me PCMB. Today we will discuss the derivation of potential due to a system of charges. As the name indicates, there is a system of charges. So we have to find the potential of that charges. System of charges consists of many charges. So we have many charges. So this is the diagram. So here I have a point P and in its surroundings I have three charges Q1, Q2, Q3. The distance between Q1 and P is R1 and between P and Q2 is R2. Between P and Q3 is R3. So we know that net potential at P or at any point will be the algebraic sum of the potential due to individual charges. So these three charges will exert a pressure, a charge to the point P. So Q1 will exert a charge to the point P, Q2 will do the same and also with Q3. So for finding the net potential, we have to add the potential created by these three charges. So V net equal to V1 plus V2 plus V3. So we know the equation of potential, that is V equal to 1 by 4 pi epsilon naught into Q by R. Q is the charge and R is the distance. We denote potential in the alphabet V. So this is the value we are getting after substituting the three terms. Potential due to the charge Q1, Q2 and finally Q3. So here 1 by 4 pi epsilon naught is common in these three terms. So we can take it outside. We can take it as common and we will get this equation. V net equal to 1 by 4 pi epsilon naught into Q1 by R1 plus Q2 by R2 plus Q3 by R3. So in this derivation we have only three charges. So if we have n number of charges, the equation will change like this. B net equal to 1 by 4 pi epsilon naught into Q1 by R1 plus Q2 by R2 plus Q3 by R3 plus Q4 by R4 etc up to Qn by Rn. So this is the point P. Here I have three charges Q1, Q2 and Q3. There is a connection. So these three charges will exert charge, individual charge to the point P. So we use this derivation to find the potential of the point. So this is the equation. This is a formula to find the total potential. If we have only three charges, so 1 by 4 pi epsilon naught into Q1 by R1 plus Q2 by R2 plus Q3 by R3. If we have n number of charges, so we have to extend this equation to Qn by Rn. So this is the equation. So now I am telling the derivation in a fast way. So here we have many charges. This is the diagram setup. So for finding the net potential, we have to add the potential exerted by individual charges. So we get this equation as the equation for potential is 1 by 4 pi epsilon naught into Q by R. So here the 1 by 4 pi epsilon naught is common, so we can take it out and we can find the equation this way. If we have n number of charges, many charges, the equation goes like this. N is a number. So this much. Thank you.